Okay, dear friend. Can you see shared page and do you hear my voice? Everything is fine? Emre? Okay, let's continue with new sort algorithm, sorting, insertion sort. The insertion sort, okay, let's write. The insertion sort is simple sorting algorithm. It is usually, of course, not the most efficient. It is, okay, it is not the most efficient algorithm. There is the advantage and disadvantage also. To sort a list with an element, the insertion sort begins with the second element. The insertion sort compares the second element, this second element, with the first element, and inserts it before the first element. If does not exceed the first element, and after the okay, I'm sorry, I open my microphone. So we start the insertion algorithm, and I start to write definition of the insertion algorithm, and so where we were, and insert is the insertion algorithm. And after the first element, if it exceeds the first element, so it is a really long definition. At this point, the first two elements are in the correct order. The third element is then compared with the first element, and if it is larger than the first element, it is compared with the second element, it is inserted into the correct position among the first three elements. So this is the basically explanation of insertion sorting algorithm. Insertion sorting algorithm. And there is the example. There is the example. Same example. Okay, you can hear my voice, right? There is no problem. You can see the shared page. Emre. And Emre, evet. Yes, there is Emre answer. And okay, you know what I told last week, there is a problem sometimes, you know, depending of the user number. I mean, there is some, you know, network problem from UBIS. Then I opened the YouTube video recording channel. I upload the what we have in the UBIS. I shared everything in UBIS also. If you have a problem, there is the, I opened the Zoom class also. I can share with you the Zoom class connection. If you have anytime any problem, please write in the chat, and then I will manage to you to Zoom class. Okay, now looks like everything is fine. Then continue to insertion sorting. Use the insertion sort to put the elements of the list. We have again same set. We won't see any set in the computer side. This is our writing 1 and 5 again in an increasing order. So we have that list, and we want to use insertion sort. Then what we have in that algorithm. So we have 3, 2. Okay, use the same method to explain what we have. 2, 3, 4, 1, and 5. And first, insertion sorting algorithm is going to compare 2 and 3. Okay, compare 2 and 3. Of course, 3 is greater than 2. Then it is going to change place of that one. Then we have 2, 3, 4, 1, and 5. So already we corrected here as a 2, 3, and 4. Because, first two elements corrected as a 2, 3, and then it is going to check as a first 3 element as a 2, 3, and 4, and it's going to see 4 is greater than 3, 4 is greater than 2. So it is going to say, so let's find the different explanation way. Okay, first checked here in that box, first 2 elements, then checked here. So here is the, there is the problem, and correct it, and corrected, and third one is also corrected. And next one, we have 2, 3, 4, 1, 5. Fourth element is 1. So we will check that element position. So this is going to be less than third element, less than second element, less than first element. It's going to order that one in that issue or that step 1, 2, 3, 4, and 5. Here we already checked that first fourth element. Then we will have that one, and then we will check as a next element with the fourth one and third one and second one and first one, it's going to say, okay, this is the correct order as a 1, 2, 3, 4, and 5. Okay, here is the check first two elements, and here is the 3 elements. Okay, make it number, but number is going to maybe confuse our mind as a 2 element correction and 3 element ordering. Okay, and next one, fourth element, I mean first 4, and then we completed with the first 5 elements. So this is the insertion sort. Yeah, there is the advantage when you compare the bubbling sort, that algorithm, but also disadvantage when you increase the sequence set, there is gonna be kind of problem depending of the memory or cache of the microprocessor and so on. So what is the pseudocode of that algorithm? So we are in page 4. Okay, pseudocode, I will try to write here. I hope. So, okay, procedure, insertion sort. Insertion sort. And we have again in our series like A1, like 3, A2 was 2 in our example, and so on. There is the AN, real numbers with n is equal or less than 2. And then for there's a loop J2 to n, and there is I1, and while IJ less than, I'm sorry, AJ less than AI, and then put I is equal I plus 1, then M is equal AJ for, I hope there is a place for K is equal 0 to J minus I minus 1, A sub J minus K is equal A sub J minus K minus 1. So this is the index of the A, and then AI is equal M. So finally I have, so now is okay. So Emre, is there any problem? A1, A2, and A sub n is in increasing order. Finally, we will get 1. Any question? Okay, page 5. And string matching algorithm. I'm sure there is so much algorithm. This is the basically known and commonly used algorithms. String matching algorithm. Okay, algorithm. Okay, if there is text sequence and finding or a pattern occurs in text string, you know that sequence is going to be string in text string is called string matching. String matching, you know, plays an essential role in a wide variety of the application, including text editing, you know, spam filtering, systems that look for attacks in a computer network, search engines, you know, there is the plagiarism detection. If there is a social science student homework, you can use that kind of, you know, algorithm to check their homework. Of course, they must be in the soft side informatics. Okay, there is the, you know, again application in the informatics, and I'm sure you can find many other application area. So, there is the, online dictionaries using that kind of algorithm also. So, is there any example? No, I don't have any example. Okay, Grady algorithms. There is so many optimization problem. Of course, when we look at our side, we have to, solve this kind of problem. The goal of such a problems is to find a solution. Is to find. Okay, is to find a solution to the given problem that either minimizes or maximizes the value of the parameter. So this is our, goal. This approach selects the best choice select best choice at each step instead of considering all sequences of steps that may lead to optimal solution. Optimal solution. Algorithms. Okay, finally, algorithms that make what seems to the best to be the best choice at each step are called Grady algorithms. So this is the main definition. And so just I will give that definition. Then finally, I will give any more. I'm looking. There is the example, but I won't give any example for Grady algorithms. And I will talk about as a next big O notation. So we saw the algorithms and some basic algorithms for searching and sorting, and we saw also Grady algorithms, and now we will consider the capability, or when we look at the outside as a big picture, what is the in that big picture as an algorithm, there is the the growth of functions. So as a growth of functions, we will talk about big O notation. So there is many kind of algorithms. The time required to solve a problem using that kind of algorithm. There's many kind of algorithm to solve the problem. Okay, anyway, I don't want to put any part of in between that sentences, but algorithms solving the problems, the time required to solve a problem depends on more than only the number of the operation it uses. The time also depends on the hardware. There is a hardware side and there is also software side used to run the program that implements the algorithm. So approximate the time required to solve a problem of a size n by multiply the previous time required by a constant. For example, computer let's say might be able to solve a problem of size n a million times faster than we can. However, this factor of 1 million, this factor of 1 million will not depend on n, so big O notation. So there is the big O notation is that we can estimate the growth of a function without worrying about constant multipliers or smaller order terms. So there is the new idea is a big O. So what is the big O? Okay, Zeynep is going to ask to keep that page in the screen. And big O notation so the growth of a functions is often described using a special notation as a big O notation. So what is that notation? The definition let's say f and g be functions from the set of integers or the set of real number to the set of real numbers, we say that f of x is O g of x is there a constant c and k such that absolute value of f of x less or equal as a c absolute value of g of x. So whenever x is less than k, this is read as f of x is big O of g of x. So this the f of x is big O g of x. So we define the big O notation, and I'll stop here, dear friend. Then, you know, maybe evening hour, we have meeting hour at 7, right? I will give some details of big O notation. Then I will continue when I complete the big O notation. What is the next? Yeah, we will complete that chapter as a chapter 3. We'll complete it. Okay, as soon as I can do, I will evaluate your, midterm exam. I know I had to announce, but I'm sorry for that. Okay, Naudur Rahman. Any question? So I don't know, Naudur Rahman.